Okay. New chapter. We will be talking about the forces and Newton's law of motion. In this chapter, we try to analyze motion, linear motion of particles, dynamic. Okay. We try to analyze the dynamic of a linear motion. In the first two chapters, okay, we talked about the kinematics. What is the velocity? What is the acceleration? The speeding up, the slowing down, moving with the constant velocity, constant acceleration. Okay, so and we did ever discuss about why this object moving with the constant velocity, why this object is stopped, why this object is speeding up or slowing down. Good. So we just talked about a kinematic of the motion. But in this chapter, we would like to analyze why the object moving with the constant velocity, why the object is not moving or stay at rest, why the object is speeding up, or why the object is slowing down, okay, in any direction. Good. So that's why we will try to talk about the Newton's law of motion, and we will start with the Newton's first law of motion. I would like you to join to the class right now and just tell me what do you know about, let me just, okay, so let me just if you wanna, yeah, go ahead and just scan the code or go to the classpoint.app and the class code is Phys120. Make sure that you are in.
The class is full.
The class is full.
When I try to join. Part of this class code is invalid and not in use.
So are you using the same? Because you don't need to change. Okay, if you already, because this is the same class. Okay, so and if you are using the same cell phone, it show the same.
Like codes one.
It doesn't let you to join the class. Oh, with the same username, yes? Okay, use the same username. What?
Yeah, which one I use the same username?
It did work?
I use the same username when I.
It worked, yeah? Yeah, use your same username because this class is the same class. If you already know your username, okay, make sure to just join with the same username that you use. Okay, so I can scroll down. If you forgot to your username, okay, you can just how many we have? 2, 5, 9, 12, 15. So we should have 2 more.
What was the code again?
The code was PHYS 120, space 120. The code is here. Yeah, make sure to just, use the same username every time that you are. Okay? Everyone in?
I'm using the code that's not allowed.
Okay. Do you know your username? If you just use the same username, okay, you don't need to disclose your username. But if you know what was the username, okay, we have MGMZ RA 1 recording. Okay, so if everyone in the class, I would like you to just write down whatever you know about Newton's law. Okay, have you heard anything about the Newton's law? And just write down anything. Okay, you can just put 5 responses. Okay, yeah. 1.5 responses. Yeah. Any law, okay, how many law we have? What is the first law? Okay, what is the second law? What is the third law? And what is the Newton's law at all? Okay, so the Newton's law is trying to explain what? So, the Newton's law is mostly focused on what topic? So it says object in motion will continue. Object in motion will continue. Okay, yes. Okay, it is the Newton's first law. It seems that some students know what is exactly the Newton's law. The first Newton's law. Object is at rest, stay at rest. Yes. It doesn't let you. Okay. And O.
So put in like 8 words.
8 word. Okay, that's it. Try to short it. Okay, as much as you can. Chemistry. Okay, I saw chemistry here. Chemistry. Newton's law chemistry. Yes, okay. So because in the chemistry, motion. Yes, we have motion. Wherever we have motion, it's related to physics. If you write the chemistry, okay, so it doesn't mean that this is wrong. Okay, it is correct. But what aspect of the chemistry? Okay, anything that is moving. When it's moving, has energy. Mechanical energy, thermal energy. We can discuss about this. Okay. So gravity. So what is the gravity exactly? Gravity is a acceleration, force. Object motion will continue. And then object move until it stop. Okay. So energy remain the same. Movement. 3 laws. Yes, we have 3 laws of the Newton for Newton's. Gravity makes things goes down. Yes, gravity, force of gravity make object to move down. Okay, so let's say you have an object, you release the object there. So how it's related to the Newton's law? Gravity is related to the Newton's which law? Second, and it's related to the third law as well. Okay, we will try to learn. Okay, today and this week and next week. Okay. So what else? Axle equal force divided by mass. Yes, this is the Newton's second law. Perfect. So acceleration is the reason that we have acceleration is because of the force. Okay, Newton's law is talking about the force because I have seen here gravity. What is the gravity force?
Basically,
Exactly. The gravity is pulling the object towards the ground. The force of gravity is trying to, pull the object toward the ground. So friction is slow movement. It's slowing down, yes? In the kinematic, we learned that we have a motion with the constant acceleration, a slowing down motion. Why cause the objects to slow down? There is a dissipative force or resistive force. One of those force here is the friction force. Sounds good. So anything, see here we are talking about the forces. Okay, what is the force then? How many forces we have? Let's move to the next one. Let me just close submission. Thank you. Okay, let me just go here. Okay, and go and just tell me what are the forces? How many forces we have? Any force that you have heard. We will try, I would like to see how much do you know about the forces, and then we will try to, explain with more details. Gravity, normal force, inertia, force of gravity, gravitational force, normal force, pushing force, friction force, applied force, pulling, air resistance force, work force. Yeah, work force. Okay, workforce. Okay, so we have, I think, we have some students here. They have an admin job. Yes. Okay, so if we have good workforce here, if you would like to hire us, we are ready. Okay, great. All of these are forces. We will try to talk about all of these forces. And we have to learn these forces to be able to analyze a kinematic of those motion that we explained. Okay? So, I saw here pulling, pushing. Good? Push. What happened?
Forward.
This is a chair, yes? What is the velocity of chair?
0.
What happened?
Push it.
I pushed it, moved, and then it stopped. There was a force, a speed up the chair, and then it slowed down. There is another force that bring the chair to a stop. External force. There is one natural force here, okay, that bring the, because when I am pushing, it start moving. What is it stop? Why is it stop?
Because there's friction on the ground.
There is a friction on the ground. There is a resistive force that bring this chair to the stop. Okay, so pulling, pushing force, we call these external forces. Some of the forces are natural forces. It depends on the quality of the object. One of those forces are friction force, or we call it resistive force. Sometimes we call it dissipative force. Okay, air resistance. You remember when I was talking about the falling the object? I said, okay, if there is no air resistance, the acceleration is constant. But when there is a resistance, air resistance, that would be different. So what exactly air resistance does? Air resistance, there is a force of gravity pulling down the object. But there is another force that opposing the object moving towards the ground. We call it air resistive force. Why? Because there are air molecules everywhere. Hydrogen, nitrogen, oxygen, and there is a contact between the object and these molecules, yes? And these molecules doesn't let the object move toward to the ground. It's trying to push it up, pulling down, resistive force, good? And then pushing, pulling, yes, we call this external force, force of gravity. Okay, we call it a long range force. What does it mean, long range force? Again, it is important. Rest, push, move. This is a ball, yes? Move. Why it's moved?
Dropped it. Gravity brought it to the ground.
Right. This one need hand to move, yes? Need contact point to move, yes? You are touching the chair is moving, you are pushing. This one doesn't need contact, yes? It's moving towards the ground. There is a force between this object and the ground that pulling the object. It doesn't need to touch. This ball doesn't need to be touched with the ground. It's being pulled toward the ground, yes? the ground is exerting force on it. We call these forces long-range forces. Sometimes there should be a contact between two objects, okay, to create a force. But sometimes there is no contact. Then there is no need to be a contact point, okay, between these two objects, this ball and the ground. This ball moves towards the ground. Good? May the force be with you. Okay, great. You know, in the first two cloud, okay, so I just wanted to make sure how much do you know about all this stuff. I see seems that you have a great understanding of the force. Okay, so we will try to explain a little more with more details. Okay, so let me just close this submission. Thank you. Go back here. The Newton's law. The first force is important. If we define the Newton's law is telling that if the object is at rest, good, at rest, stay at rest. If the object move with the constant velocity, forever. If is important. If there is no forces, or if there are forces, these forces cancel each other. Okay? Here. Good. Chair. Good example. It's not moving. It's not going to move forever if there is no force acting on it. Yes?
Right.
If I exert force, this will move. If there is no force, if it's at rest, it stay at rest forever. We call this equilibrium. Static equilibrium.
Well, there is a force, right? Gravity, because ground were shift a little bit.
So there, you know, when we say there is no force, it does have two meanings. There is no force at all, or if there are forces, these forces canceling each other. See? Forces canceling each other.
So it has potential energy too, since it's moving, it has the potential to move.
Yes, okay. We are not talking about the energy, okay? So we just focus on, yes, definitely these have a potential in it, okay? So, and we just focus on forces because the Newton's law focus on forces. Good. So what is the Newton's first law? If the object is at rest, stay at rest. If the object move with the constant velocity, move with the constant velocity forever. If there is no forces, if there are forces, these forces cancel each other. So it means that the net force again is zero. There are two forces here. Can anyone say how many forces we have is being exerted on the chair? Two forces. One is a normal force, I will explain later, okay? Which is keeping this chair on the ground. The other one is force of gravity. We definitely know that there is a force of gravity is downward, yes? It's downward. It's trying to go toward to the ground, but it's not going toward to the ground. There should be other force in the opposite direction of the force of gravity. This force is a normal. Good? Anything, any object which is in the surface receive a normal force. This normal force is always perpendicular on the surface. Perpendicular on the surface. Good? So, but we said that if the object in the Newton's first law, if object is moving with the constant velocity, it moves with the constant velocity. So, again, anytime the object moves with the constant velocity, it means that no force is exerted. If there are forces are exerted, these forces cancel each other. Because force and acceleration in the word cloud, I saw that one student wrote acceleration is equal to the force divided by mass. So it means that whenever there is acceleration, definitely there is a force. This is a Newton's second law. Newton first law, object at rest or object move with the constant velocity, there are no forces. If there are forces, cancel each other. Newton's second law is telling that if the object is accelerating or decelerating, definitely there is a force. And these force and acceleration are directly related together, are proportionally related together, okay? So, we talk about the forces. The forces is, we can have external forces or natural forces like force of gravity or force of friction, or external like pulling and pushing. The unit of the force is Newton. Because of the Newton, okay, we just use this, okay, for. So the unit of the force is Newton. Okay. Net force. What is the net force? Net force is when we are adding all forces which are exerted on the object. Good? So one of the forces is the applied force, pushing or pulling. We have a box here. Good? We have a box here. Good? And you are pulling this box with forces. How many forces are exerted on a box? Two forces. Yes, 5 Newton and another 5 Newton. What is going to be the net force? 10. 5 is going to be 10. We are adding forces with their sign. Force, again, force is vector. It does have magnitude and direction. Perfect. So these two forces are in the right side. When I am adding forces, I should add forces with their sign. So net here means adding all forces. Good? With the sign. How about the next one? The second one. How I can write? Okay, there is a box here and there are two forces, one to the right, one to the left. And I'm supposed to calculate the net force. How I calculate the net force? I add forces with their signs. So how I add these two forces? If I write the second one, so I write it here. So it's going to be, the first one is going to be positive 5n. Again, adding net force means adding, plus what is the other force? Negative 5, you know. 5 plus minus 5 is going to be 5 minus 5. Yes, it's going to be 0 Newton. That's why we have. Last one. We have a box. Good. Two forces are exerting. 10 Newton to the right. These are the applied forces or external forces. Positive 10. Again, plus. What is the last one? Negative 5. Positive 10 plus minus is going to be minus 5 Newton. Positive 5 Newton. The resultant force or the net force is going to be 5 Newton to the right. Good. So force is a vector. It does have direction and magnitude. When you are writing force, you should write force with its magnitude and sign. Positive means that the force is exerting to the right side of the coordinate system. Negative means that the force is being exerted in the left side. Good. Why we are trying to calculate the net force? You remember what Newton's first law and second law? The first law is telling that the net force is zero. Or there is no force, or there are forces. These forces cancel each other. So it means that it is very important if you are analyzing a motion of particle or moving object. First of all, you need to identify forces and add these forces. When you add these forces, if it's become zero, Newton first law. If it's not zero, Newton second. Make sense? That's why net force become really important when we are analyzing a motion of a particle. Any question about net force? Is it clear? Equilibrium. Okay, let me just. Equilibrium. What is equilibrium? Write down anything that you know about the equilibrium. Equilibrium. Anything that's equilibrium. You can search, okay? So you can search even to see what the equilibrium means. You can search what is the equilibrium in physics, what equilibrium means, and then try to read it, analyze your reading, and then put equilibrium in physics. And what kind of equilibrium we have in physics. Yes. So, gravity. What is the any force that prevents object from the movement always let's say
Can't be the
gravity it depends on how you are looking at the problem. Sometimes force of gravity can be for one situation can be but it depends on what problem you are analyzing.
Okay.
What kind of motion you are in.
Okay.
Let's say I'm just trying to wait, shuffle it. So you're trying to move a thing from the ground. Then you're told to get force of that.
Okay.
Makes sense?
Yeah. Thank you.
Okay, let's see what we have. Equilibrium is equal no movement. Not always correct. Yes, when there is no movement, we have equilibrium. But sometimes we have a movement. Sometimes we have movement. You remember Newton's first law? If the object is at rest, it will stay at rest forever. If object moving with the constant velocity, it move with the constant velocity, but there are no forces. If there are forces, these forces cancel each other. So it means that equilibrium, yes, no movement, but sometimes we have a movement if it's moved with the constant velocity. That's why we have two kinds of equilibrium. A static equilibrium, kinetic equilibrium. A static equilibrium. This is a static equilibrium. If the object is moved with the constant velocity, this is kinetic equilibrium.
Wouldn't constant velocity only exist in theory though?
Yeah, yes.
Because obviously distance is infinitely divisible. And with the imperfections of just the world and atoms, I would think you could only really get a perfectly smooth movement at a molecular level, right?
Yes. You know, if you would like to look at a real world, okay, so what exactly happening in the world macroscopically and microscopically inside the atoms, okay, or macroscopically between the planets, okay, so you cannot say that there are a lot of factors that you can bring into your analysis to say that yes, there is no, the net force is not zero. Okay, the object is not moving with the constant velocity. This object is accelerating. Okay, so and it depends because in the physics that we learn, we try to simplify the or analysis as much as we could. Okay, we can just make this free fall motion very complicated motion with very complicated analysis. But in this physics, we just say there is no air resistance. Try to simplify. There are other forces, okay, that it is related to this. So again, it depends on how you are analyzing the problem.
I guess if we're just rounding to kind of the same level as most of the rest of our experiment, right? Which is mostly eyeball, right? If we're
Yes.
eyeballing the rest of it, then it's probably fine to round it to the point of eyeballing it, right?
Exactly. Yes. Yep.
So
So effort and load. Okay. A state, stable. Forces cancel out. Yes. One of Newton's law. Yes. Newton's first law is equilibrium. Equilibrium is Newton's first law. When opposite forces are equal. Opposite force, there are forces, but they are canceling each other. Yes. Gravity versus force of gravity versus force of ground. I know the gravity, force of ground. What does it mean, force of ground?
Like the, I think you called it like the normal force, like that.
Normal force, yeah. Force of the ground, okay, yes. Yeah, perfect. Chair, good. Force of gravity, but there should be another force that, because if there was not normal force, these move toward to the ground, not stay still, yes? So, perfect. We all know the equilibrium, okay? Any question? Oh, no. Let me just close. The equilibrium rule is telling that when you're analyzing a system, what is the system in physics? You are analyzing this chair motion. You will say my system is just this chair. And now you would say there are two chairs. I am analyzing a motion of these two chairs. What is my system? These two chairs. And I am analyzing motion of anything which is inside the class. What is my system? The class with all objects antecedent inside the class are my system. Good? We are in the class, yes? The class is not moving, but we are a particle inside the class when we are moving. The class itself is in equilibrium, but the particle inside the class which are moving, they are not in equilibrium. See how we, it depends how you define your system. It is important. So when we have a system, for instance, in this picture, we have a person, two persons. They are in a level. There are strings, yes? They are strings. I don't know why. They are two string. They are trying to hold these two people and the level. Because they are trying to paint. And you have seen this a lot. Right now, this person is trying to walk. Good? And the entire system is in equilibrium. What is the entire system? These two person, the level, and the string. What was the net force then? If the system is in equilibrium, you mentioned in the word cloud that the net force should be zero. I need to identify all forces which is exerted on the system and then add all together. If it's become zero, the system is in equilibrium. If it's not zero, definitely there will be not, the system is not balanced. I saw the balance word, okay? So that's a good word for equilibrium. There will be no balance. So it means that the net force is not zero. There is a force. Good? So it is important if we are trying to find out the system is in equilibrium or not. One thing, identify all forces and add the forces in the same direction. Add forces in the same direction. Third, if they become equal zero, if it's become the net force becomes zero, we have a equilibrium. And this equilibrium can be a static equilibrium or kinetic equilibrium. In this system, which one of the particles inside the system has kinetic equilibrium? The walking person, yes? The person is walking, the entire system net force is zero. This person does have kinetic equilibrium. How about the level? Not moving, yes? How about this person? Not moving, okay? And the string, not moving. Static equilibrium. The entire system at all, we say that the entire system is not moving. The entire system at static equilibrium because all of these persons, they are balanced. Yes.
Dynamic.
Kinematic is the dynamic. The same. Dynamic equilibrium or kinetic equilibrium, they are same. Okay. No question. Static when there is no motion. Okay. Okay. Go ahead and try to answer these questions. Let me just change the word cloud, okay, to word cloud. Image. Okay. So try to think, okay, when you done, you can just upload your answer here, okay?
Do you want the answer?
Exactly, okay. The question is, okay, so we are trying to practice the equilibrium rule. So we have three systems, yes? The first one, the person is in the middle and 500 Newton here. What should be the here?
500.
Okay, yeah, just try to answer. Okay, so yeah, and then upload the picture. 170, what should be here? 0, what should be here? You can do one per group, yes. One per group, that's okay. Or you can do in the intro. Completely up. As I said, first identify all forces. Good. So far, you know what is the force of gravity, yes? Okay, 1 minute. If you have access to the PowerPoint, the next page does have the answer. Okay, so you can even look at the answer, okay, to double check your answer with the. Okay, 30 seconds. Make sure to upload your. Good. Okay. Okay. If you haven't submitted, I'll just give you how many tables we have? 1, 2, 3, 4, 5. We need one more table. Okay. So let's see. Thank you. 500, 830, 1000. It would be better, okay, to draw good objects and then forces to show what is the forces, how you find the 500. Good. So yeah, that's correct. So let me just, okay, this one is better. So you have 500, and then there is a person in the middle, and there should be another 500. Okay. And but how many forces we have? We have two forces, upward forces, but it means that there should be downward forces as well, yes? Because 500 plus 500 is 1000. Net force is 1000. Good. What does it mean? It means that there should be another force downward, the weight of the person and the level, yes? 1000. Good. We have two upward forces, 500, which is going to be 1000. There should be one downward forces to make the equilibrium. Yes, to make it a static equilibrium, or net force become equal 0. Okay. So the next one, here, let me just. This person is close to one of the string. This one is 170. Good. The total was 1000. If we want to bring this to equilibrium, if the upward force is 170, yes, the other force here should be 830. Two upward forces become equal 1000. Downward forces is already 1000. Yeah. And the last one, zero force, But we already know that this person and the level together, they have 1000 Newton, or it is a force of gravity, or the weight of this person, the weight of the level and the person. You know, another word for the force of gravity is, weight. Force of gravity is weight. Right now, when I ask what is my weight, it means that I'm calculating my force of gravity. If I calculate the force of gravity, the gravity force which is exerted on my body by the ground, I am calculating my weight. This is going to be my weight. Good? So it's going to be 1000. Okay, let me just draw a little better. So see here, we have 5,000, sorry, 500. Good. And definitely, okay, there will be a force between force of gravity which is exerted by the ground to this person and the level. And this force of gravity is always toward to the ground. We call this, okay? Because the system, there is a symmetry, whatever the force, and this person is standing in the middle. If this is 500, if we want to keep it balanced, this should be 500 as well. Okay, right now we have two string forces, yes? The forces which is exerted on the level by these two strings, we call these force tension force. Tension force. Now we learned one more force. Tension force. When the object is connected to the rope or the string, if you pull the string, you are exerting force on the string, the string exerting force on the object. It's called tension force. Your force is applied force, external force, but the force that this rope is exerting on the box is going to be tension force. So these two are 500, and we said that this person and the level together should have how many thousand Newton weight? How many weight? How many Newton weight? Thousands. Okay, perfect. From here, because of the symmetry of the situation, yes, I would be able to find out the weight of the person and level. And the weight of the person and level, or force of gravity of the person and level, yes, is always 1000 Newton. So I'll just keep drawing 1000 Newton for these two everywhere, yes? 1000 Newton. Good. So I am supposed to find the tension force which is exerted on the, so what is going to be the tension force here? If this is 170 and this is 1000, okay, if I add these two, yes, if I add these two, okay, it should be, if I add all forces, it should be 0. So 170 upward. What should be the another force upward to make it equal to 1000? 830. So 170 plus 830 is going to be 1000 upward, and there is a 1000 downward. Okay, the system is in equilibrium. Okay, here there is no force. We assume that there is no tension force. Okay, so if this is 1000, yes, if this is 1000, this should be 1000 Newton. Upward force again should be equal to downward forces. It's become 0. Okay, so most of the group, okay, they got the right answer. Okay, I just kind of going to show with details. Okay. Yeah, and if you want, you know, the explanation in the next page, okay, is explained. So here, let me talk about all forces. Thank you. Talk about all forces that we need to know. I just said we have, let me just open a new page. First force is the applied force, yes? What are the applied force? Pushing, yes? Or pulling. So, or sometimes we call them external forces. Okay? So what does it mean pushing, pulling? Everyone knows what it means. The second force I would like is the force of gravity. Force of gravity or weight. Sometimes we show it with W or sometimes we show it with FG. F with and this G, okay? And we can calculate the magnitude of the force of gravity. How? The magnitude is mass time G. The mass is in physics, in a standard unit, the mass should be in kilogram. Do not use pound. Mass is in kilogram. Mass is in kilogram. And the G, what was the unit of the acceleration? Perfect. Meter per second squared. If you have a mass, multiply, let's say my mass is 80 kilogram. I multiply 80 by 9.8, I can calculate the force of gravity or my weight. Good? Example. Person with a mass of 80 kilogram, what is the weight? Weight is going to be 80 times 9.8. The weight of the person, good, is going to be 8 times 9.8. 80 times 9.8, sorry. 80 times 9.8 is going to be 784. 784. What is the unit of the force? N or Newton. Let me just write it. You see here? Kilogram meter per second squared, yes? Another unit of the force is kilogram meter per second squared. Or we say 784 or 784. The unit is going to be kilogram meter per second squared. Good? Both are correct. Newton or kilogram meter per second squared. It is important. What is the unit of the force? Newton or kilogram meter per second squared. Same thing. Okay, if I want to show the force of gravity, how I can show the force of gravity? Example. The ground and the person is standing on the ground. Good? And we know that the ground is exerting force on the person. It's trying to pull the person toward itself. And if I draw the direction of the force of gravity, what would be the direction of the force of gravity or weight? Toward to the ground, okay, or downward. So I said that the weight of this person or the force of gravity is always down. In the Newton's third law, you will learn that if there are two objects, there are action and reaction. How many objects we have in this system right now? ground and person, two. If the ground is exerting force on a person is exerting the same force on the ground. Okay, we will talk about this later, but just letting you know. Newton's third law, action and reaction force. Good. Force number 3, normal force or support force. Can you tell me in this example, in the previous example, where is the normal force? This person on the ground. I am on the ground. Am I in equilibrium or not? Static equilibrium. What kind of force is being exerted on my body? I already know the force of gravity is downward, but if I am in equilibrium, there should be other force. There must be other force in the opposite direction, yes? That doesn't let me go toward to the ground, inside the ground. This is called normal force or support force. And I can show it here. I just use Fn, or sometimes we show it with or N. You see in different formats. Okay, Fn means force of normal force, or N, just N. We call it normal force or support. And this force, again, is important. This force, the normal force, is always perpendicular on the surface. What is the surface here? The ground, yes? The ground here is acting like a surface. And the normal force is always perpendicular to the surface. Good? Okay. Next one. Number 4. Tension force. Tension force. What is the tension? Let's say you have a box and the S string is attached on the box, yes? And you are pulling the box, yes? So we would like to identify forces. So far we have learned some forces. Okay, tell me how many forces are exerting on this box?
Gravity.
Force of gravity downward, yes? Normal force? Tension force. Why tension force? There is a string, yes, or rope, and the box. There is an interaction between this string and this box, yes? This is a contact point between the string and the box. The S string, you are trying to pull the S string, you are exerting force on the S string, but the S string is exerting force on the box. This force is called tension force, and we call it with Ft, or sometimes they show it just T. Number 5, spring force. Yes. We will talk later. We assume that we don't know anything about the friction force. Yes, there is a friction. Okay, so number 6 is going to be the friction force. Good? Yeah. So, yeah, I just mentioned all of this. When we are analyzing a system, we need to look for all of these forces inside the system. A spring force. So a spring. When there is a spring, yes, instead of rope, there is a spring. So the S spring will we will have a spring force. For instance, let's say we have a spring is attached to the wall, and then the object is attached to the spring. Good. What kind of force we have? How many forces is exerted on the block? The first one is force of gravity. Okay. You know, you attach the object, see here? You attach this object. This object does have a weight or force of gravity. You attach because of the force of gravity. Okay? The force of gravity is there, yes? But there is the other, the system is in equilibrium, yes? What other forces is exerting on this anchor? A spring force. And this spring force is exactly equal to the force of gravity. That's why the system is in equilibrium. So whenever we have a spring, the spring will exert force on the object. This force is called a spring force. And we just showed the spring force with F S. If the system is in equilibrium, yes, Fs should be equal to Fg if it is in equilibrium. But you will see in the Thursday lab that not always in the equilibrium. The last one, oh, 6, friction force or resistive force or dissipative force. Okay, and we show the friction force with this. What is the friction force? Any force that prevents object from the motion is called friction or dissipative force or resistive force. And it depends on the quality of the object which has a contacting point with any other object. One thing that is important, we have force when there is an interaction. There is no interaction, okay, or there are interaction, these forces they cancel each other. Good. When there is interaction between my hand and this chair will move. So when we are talking about any forces, there should be interaction. So, and let's say we have a box and you are trying to use this rope and to pull this box, but between the box and the ground, there is interaction. So far we assume that between the box and the ground, there is just only one interaction, long range forces, force of gravity. But we know that there is a contact point between the box and the ground. If you look at this system, okay, the contact point here between the box and the ground, you will see the microscopically they are exerting force on each other. Okay, if you zoom this part and make it bigger, you will see this part with this part is going to be this side of the box. Okay, if you look at the ground, there will be, you know, see, if you zoom with the microscope, okay, you will see that there is a contact point between the box and the ground. You are trying to pull, but the ground is trying to keep the object. These create a friction. We call this friction force. Okay, so right now, identify all forces which is exerted on the box. How many forces we have? First, force of gravity, yes? What is the next one? Normal force, because in the up and down it doesn't move. Okay, force of gravity should be equal exactly to the normal force. There is a contact point between the rope and the box. There will be a tension force. Good. And there is an interaction between the box and the ground. Okay. Friction force. And what is the direction of the friction force? Opposite from the motion or opposite from the tension. It's always because we are trying to move the system to the right. Yes. But the friction force is preventing the object from motion. The direction of the force should be opposite direction of the motion. If the system is moving to the right, the friction force should be
equal to the length of the one in class because you're still
okay, it depends. Okay, so if the system, good question. If the system accelerating, what does it mean?
force is stronger than the
Perfect. The tension force is speeding up, so it means that the F tension, yes, is bigger than friction force. Good. If the system is in equilibrium, so what does it mean? It means that it's not move, yes, or if it move with the constant speed or velocity. Good. At this point, what does it mean? Perfect. Tension should be equal to friction force. Make sense? Good. So we have two kinds of friction. If the system is in equilibrium, okay, let me just separate these two. If the system is in equilibrium, we have a static friction. I call Fs, a static friction. Good. But if the system is moving, okay, if the system is moving, it doesn't matter, is it speeding up or moving with the constant velocity. Good. We will have a kinetic friction. So it means that there is a friction, but this friction is a kinetic friction. Okay. So we just learn, we will try to explain not too much. Okay. In this physics, you just need to know what is the friction, what is the direction of the friction, okay, and how many friction force we have. We have a static friction and kinetic friction. Good. So, and there is a, and these two force, and there is two more force, okay, we call them thrust force and drag force. But again, these two are kind of, the thrust force is the applied force, good, or external force. Drag force is friction force. I said friction force, air resistive force, dissipative force, okay, any force that preventing the object from motion. Good. So thrust force and drag force, okay, is part of the applied force and the friction force. Yes, okay, we kind of, okay. We will just, as I said, the force is a vector, and Thursday, when we are talking about the lab, okay, I will try to talk about the vector first. Good. In 10 minutes, and then we will start our lab. Okay, for lab, please review the lab handout. and then come to the class prepare. Okay, any question? Have a great day.
Thank you, Professor.
Thank you. Bye.
I know.
You too.